Hi everyone. We left off the last video with this looking at the study of charter schools and their influence on public schools, and then that's an observational study. It uses some good administrative data on school districts in Texas, and the researchers attempted to kind of account for things that might be different about districts that have charter schools, um, and that also may be influencing the performance of the public schools in those districts. So they chose a range of control variables to include. So let's look at some how to choose control variables, what the researchers might have done, and also maybe what not to do when trying to choose control variables. I should point out that the third assignment that all of you are going to do involves the task of coming up with some control variables, and it's important to just sort of know how know that skill as if you're going to do your own kind of control variables analysis, which you can do, with even with Excel and some some data in Excel, but also when you're looking at studies that use control variables, this skill of thinking about how to choose control variables is useful for judging the sort of the quality of evidence when you see studies that use this approach. So let me just point out that simply using control variables of any kind does not solve the problem. It does not eliminate the bias, because there's no standard set of control variables. Some studies tend to use things like socioeconomic status, gender, age, race, and other basic demographic variables. Those things can be important, but just using them doesn't guarantee that the results of the study are unbiased. You have to use the right set of control variables for the study, and some of them may be kind of unusual and unique to the particular situation. So just using control variables doesn't necessarily guarantee that the study is unbiased. And then, but it's also true that you should have, or the researchers, or whether you're doing your own analysis, they should avoid the kitchen sink approach. You shouldn't just throw everything that you have in the data set into the control variables, because it turns out that you can actually make a mistake by over controlling or putting in too many control variables, and that can make things worse than having not included control variables. So those are some considerations. Now, the best kind of control variables are ones that represent common causes. So the focus should be on common causes, and those are variables that are either influenced or associated with X that also cause Y. And the only way to really do that is to theorize or think theoretically, as well as use empirical evidence. And it's also important to think about potential complex common causes. The notion of a common cause can sometimes be a little confusing, because things may not directly cause X but be associated with X. So the districts that have charter schools may have, let's say, larger class sizes. It could be that larger class sizes lead to frustration on the part of parents, and that leads to the creation of charter schools. But there can be some complex common causes that nevertheless need to be accounted for. And we talked a bit about common causes last week when we talked about causation. But the notion is that theory and thinking carefully about what might be driving both X and Y is a key part of picking control variables. And so hopefully the researchers did a good job of that. And in a good study, they should explain why they chose the control variables they did. And then here's another point. It's important not to control for intervening variables. This is related to the problem of throwing too many variables into the analysis. There could be variables that are causal mechanisms, and so let me look at both these points, and I'll look at them. I'll show you them graphically. So here's the notion of a common causes, and this is from the book. So let's say we're interested in the effect of education on earnings. What makes for good control variables are variables like, let's say, the parents' education, which might both influence parents with a higher level of education, may push or be able to help children get a college education, but that same advantage that parents have may also help their child get earnings because they can make connections and help them with internships and first jobs and that sort of thing. So it could be more educated parents both encourage kids to go to college and help them with their careers anyway, even had they not gone to college. And so part of the college effect may be due to that. So if that would be a common cause and therefore something to control for, and also some measure of aptitude or general academic ability might influence, of course, whether someone completes college, and regardless of whether they went to college or not, that same aptitude would influence their earnings. So we want to, in other words, we want to take this college and earnings effect and we want to remove from it possible drivers of both X and Y. And that's what these common causes are. And those sorts of variables are the best candidates, or those are good candidates for control variables. And what we don't want to control for is something that might represent the causal mechanism or the way in which X has an influence on Y. So let's say being college educated leads you to write better, to be a good communicator, and then that influences the kinds of jobs you can get because you're able to write and communicate better, so you get higher level jobs with higher earnings. If that's the way that college has an effect on earnings, then we would not want to control for writing ability. So if we had a sample of adults, we wouldn't want to say, oh, well, controlling for their ability to write well, college has a limited effect on earnings, especially if writing well is an ability that college bestows on people and that the labor market rewards. So you don't want to control for those sorts of intervening variables. But sometimes it's complicated. You may not be able to distinguish necessarily common causes from intervening variables, and so this is not easy stuff to do, but these are some general guidelines. So here are some steps in the process. The first step is to speculate on common causes. It's a theoretical step, and that helps you think about what should be controlled for. A second step, which we haven't yet talked about, is more empirical, and that is to actually look for variables that are related to both X and Y. So in other words, look at the data, look at correlations in the data. A correlation, what's called a correlation matrix, is often helpful for this. And then just look for variables that are highly correlated with both X and Y, and think about why they're highly correlated with X and Y. And those variables are good candidates also for control variables, because you know empirically that they are both related to X and Y. And then finally, step 3 is to incorporate your carefully chosen variables in the analysis. Okay, so let's now look at some advantages and limitations of this control variable strategy. So some of the advantages, well, it's certainly better than simple correlation or naive associations between two variables. So we might notice that, in the districts that have charter schools, the scores seem to be higher than in the districts that don't have charter schools. Maybe, the charter schools competition is working. So the simple correlation of two variables often begs the question, well, maybe there's something else going on with these districts that may be the real cause of performance. And if you account for those other variables, and if you account for a range of those other variables, and you choose them carefully, it beats simple correlational evidence. And another advantage is that these sorts of studies often involve large real-world data sets, like the Texas school system data. That's a big state with hundreds of thousands, probably millions of kids, and it's real educational data. So it allows us to look at cause and effect with real-world, large-scale data, which is an advantage. Many experiments are small-scale, sort of laboratory or small-scale field experiments. And it turns out that if you have the right control variables, right, if you have really the really important, if you have all of the right control variables, it's been shown that results are actually fairly similar to a randomized experiment. So in some ways, if you do a good job with the control variable strategy, you can get close to what would be experimental evidence. So, but that's a big if, because getting the right control variables depends on having the right data, and that's often a limitation. So let's now look at the disadvantages. So one big disadvantage is not having the right control variables in the data set. And I've alluded to this before, but this strategy depends a lot on having a measurement of the control variables that are important. And data sets don't measure everything, surveys don't measure everything, school systems don't measure everything. And so if we have if we're missing a variable, there may be some bias, sometimes called omitted variable bias, because some of the important control variables are omitted from the analysis. Another limitation related to that is just not knowing which control variables are the right ones to use. So we may have a simple lack of theory and knowledge. No matter how hard we think about it, we may just not correctly identify the right control variables to use. And a big limitation, which really, no matter what else we do, we can't quite solve, is the problem of reverse causation. If for some reason, particularly with cross-sectional data, if causation works the other way around, let's say if performance is related to the existence of charter schools in a district, and we don't have any sort of time order or any kind of longitudinal data to tease that apart, which comes first and which comes second, then there's nothing we can do, even with the use of control variables, to figure out the reverse causation problem. So those are some of the advantages and limitations of observational studies and the use of the control variable strategy.